What's up, YouTube? In today's video, we're going to be talking about delegates. Now, I know, you're thinking, I don't need to know about delegates. I've been doing C# for 15 years, 18 years, whatever the number is, and delegates are like, I know that. If you're new, certainly you should watch this video anyways, but even if you've been doing C# for a long time, I can almost guarantee there are things in this video about delegates that you may not have known. And the reason is because, as is usual or common with my C# series, I take the kind of the mundane, if you will, the foundational stuff that people take for granted that they know because they've been doing C# for a while, and I dig deeper, give you a deeper insight into a technique or a technology or a concept in C#, right? So, delegates, what are they? Why are they called delegates? We're going to be exploring a few things, some basic, well, I don't know if it's basic. It's when you see the code, you're going to say that's basic, but you may not know that that's how things work. So I don't want to kind of dissuade you from watching further. It's going to be interesting, but towards the halfway point, I'm also going to be talking about higher order functions and building one of our own. Now, I did such a thing in a previous video recently about maybe like a year ago, and I did the first part of the video in another video called So You Think You Can Link, like 7-8 years ago. But I think because that video was so long, as it covered so much about Link and it was in 2 parts, people think, again, it's one of those things, oh, Link, I know Link, But if you think you know Link, you need to watch those videos as well, because that's the title, right? So You Think You Know Link, and the title of these series is So You Think You Know C#. And there's a reason for that, because I deal with a lot of developers on a day-to-day basis, and I'm not even talking about the same set of people. I'm dealing with multiple people, as in different people, on a monthly, weekly basis, and I always find these things missing. These are senior engineers, and the reason I bring these things up about So You Think You Can C#, or C# is for the same reason. There are gaps in people's fundamentals, understanding of C# in this case. And as a senior engineer, you certainly need to know these things. So the point of these series is to say, okay, even if you're a senior engineer, you still may not know some of these things. And if you do, you probably know it to the depth that you probably should know. And that's why this series exists. So without further ado, I'm going to get started. And we're going to take a look at some simple code that might be baffling. That's the point. All right, so I have here defined a delegate. So, and this delegate says it's a delegate that returns a void, and it takes a string argument. The name of the parameter is irrelevant. It's just the basic signature of the delegate itself that is important. And that's the type of the delegate, just like that's the type of this class, right? So my ID just colors. I've just set the color for delegates to a different color, so they look kind of different color, but basically they're both types. In C#, there is a type. So what is a delegate? Why is it called a delegate? Now, if you understand the English meaning of the word delegate, it is like you're delegating some work to somebody else. And some people say, oh yeah, this function pointer. Not quite. Yes, you're sort of on the right track that it's a function pointer. But it's quite a bit more than that. And the reason I'm saying that is because if you think of it as a function pointer, you're not probably making the best use of delegates. And that's the point of this video, to get deep under the hood and make you understand what delegates really are, and also make you understand the syntax that you would encounter. And then towards the end, as I said, using higher order functions, it's something that functional programmers do, for example, and we can do the same thing and have been able to do the same thing in C# since the very beginning, since delegates have been part of C# 1.0 and onwards. And that's the funny thing, right? Since delegates have been around for so long, people are not focusing on the fundamentals, and they're focusing on, I want to learn about Web API or ASP.NET Core or some of these new things when the foundationals are weak. And I prefer to see a senior engineer who has a solid foundation, because then you can build a skyscraper on that solid foundation. So, yes. This is a delegate, this is a type, and that's the signature, if you will, of the delegate. But essentially, what is it delegating to? Like, what is that? And I know you probably say, delegates to a method, but why is this called a delegate? Isn't this doing the work? Right? And so to try and explain that, you have to see some code so you understand my question probably even better. Now, under the hood, at compile time, that line of code that says, that defines the delegate and the delegate keyword is, oh, by the way, we're also going to be looking at anonymous methods, delegates and lambdas, and I'm trying to understand what is the difference and or similarities between these three things. Because again, it's very vague in people's minds. And I want you as a senior engineer to understand this so well that you can explain that to somebody else just like that, right? There's no kind of guesswork involved, and there's certainly no half-assed, answers involved either. So at compile time, the compiler takes that delegate and it converts it to a class definition. The class name will be, in this case, called transform delegate. And this class descends from multicast delegate, which is a built-in .NET type. So that's the first thing that happens. In other words, delegates are a class. And then you need to create an instance of that class, and then you can work with it as a class. Now, multicast delegate has some methods on it. It's called a multicast because there was I don't know if it's called single cast, but in .NET 1.0, there were two kinds, the single cast version and the multicast version. And in .NET 1.1, they decided to not use that single cast version, and all delegates descend from multicast delegates from .NET 1.1 onwards. Multicast is essentially sort of like a observer pattern where you can have multiple subscribers. So events are based on delegates, and you can subscribe multiple methods to a single event. Let's say a button click, you can say, when you click this button, I want these 5 methods to be called, of these 5 subscribers to be called. And that's why it's multicast. All right. So the first thing to understand is that these delegates are nothing but classes. At compile time, this gets converted. I mean, not JIT time, just compile time. It gets converted to a class definition that descends from multicast delegate. And the delegate has a method called invoke on it. So basically, it's invoking something, right? So let's take a look at that initially. So let's say I have a variable defined here of type A, B, C, and D. So I've defined 3 variables of type transform delegate. And now the delegate signature says it's a method that returns a void and takes in a string. So what I'm going to do is define a method here. I'll make it void right now. Now the name of the parameters are irrelevant. The signature is important. I'm just going to give it the same name, so that makes sort of sense. And over here, I'm going to say this is method 1, and whatever the data may be, type out to the console. And I'll also have another method called method 2 that does the same thing. Just change this to method 2 instead. Same signature. So both these methods have the same signature. They return a void and they take a string argument. So I could say A is equal to method 1. Do you wonder about that? Like, what exactly is going on? I mean, that is insane. What the heck are you doing there? How are you able to assign to some variable A that's not even been initialized yet to something called method 1? And this method 1 is not a type, it's just a method in some class, right? How does that work? Have you ever questioned that? Have you ever wanted to know? Because most times, what we do is we learn a syntax and we kind of go with the flow, if you will, right? We memorize how to use something because we don't quite understand it. And delegates are a classic example of that. You use it, you know how to use it, but you just don't quite understand what's going on. Question everything. Because when you start to question things, you start to learn things. So to explain this, you have to understand or remember that this is a type, and that is just a variable of this type, and this is a class. So if this is a class, maybe what we could do is something like this. We could say new transform delegate. Let's see what it says in the method signature here. It says void string target. yeah, good luck with that. I mean, I actually never didn't understand that syntax for the longest time. Okay, but because I understand delegates now, I can make sense of it. Of course, when you're starting out, you don't understand it, so you usually can't make sense of it anyways. I don't know why they did that. That was way before we had generics in .NET, so that was sort of the signature that they followed. And this is very much like a C++ kind of signature, if you will, right? So what it's saying is, it's a method that returns a void and takes a string argument, and they're calling that parameter a target, right? So it's just the name. Target is just the name. So what it's saying is it needs a method that has the signature void returning string argument, one argument, and they're calling it target. And here you can give it method 1. Okay. So does this make sense to you now? Of course, now it makes total sense. What that syntax is doing behind the scenes, again, at compile time, the compiler writes this code. So the convenience, sometimes the sort of the language, the syntactic sugar as we call it in most languages, that helps us or makes it convenient for us to be able to use a certain feature, gets in the way of us trying to understand what is going on under the hood. So that's essentially what's going on under the hood. So we can now understand that we are saying, hey, transform delegate instance, whatever that instance is, in this case A, please delegate. When you are called, delegate it to this method, and therefore these things are called delegates because they are in fact delegating to a method. But the A is the delegate, as we call it, is an instance of a delegate. Then it turns delegates to method 1 in this case. All right. So if I were to run this application, you'll see that, oops, I didn't implement that. I did. Oh, I didn't call it. Sorry, my mistake. So I call it with, let's say hello. So I'm calling the delegate, and the delegate in turn is delegating to the thing we asked it to delegate to, in this case, target 1. However, these are multicast delegates, so keep that in mind. So I have to look at the output here. Didn't run that. Okay. So you can see now that it says method 1 hello, right? So it's called method 1. And this is sort of normal. I mean, everyone would say, yeah, I know this stuff. Okay, but just hang on. What I can do now, I could say is, okay, then B is equal to method 2, right? And I'm going to just get back to this sort of the more succinct signature here, so we don't have to see all the clutter. But you have to understand that's what's going on behind the scenes. Okay, and then I say D is equal to A plus B. Oops, I didn't mean to capitalize that. A plus B. And I'm thinking, what? Yes, they are multicast delegates. So just like in events, you can say, plus equals. I'm saying that D is equal to A plus B, which essentially means A and B are both subscribed to D, or D is subscribed to both A and B, but A and B in turn are subscribing to methods 1 and 2. Method 1 and 2. So when I call D, it should in fact call the delegate A and also call the delegate B, and therefore whatever the delegate A is delegating to, and whatever the delegate B is delegating to, those two methods should be called. So if I then call D, we say world, and I run this application now, you'll see that we have method 1 for hello, method 1 world, and method 2 again for world. So the reason maybe I should just not have this call here, right? So I should call A just so you don't get confused here. So we're just basically calling one delegate here. Okay, so now you can see both method 1 and method 2 were called. So this is the multicasting feature of delegates. All right. So if this is clear, now I'm going to move on. I'm going to up the ante a little bit. I'm going to make things a little more, switch into high gear, if you will, so you can get a little more confused. Okay. So now let's say I'm going to remove all this. I don't necessarily need all this now, but let's say I have a collection of numbers that is nothing but enumerable.range from 0 to 99. Okay. And let's say I want to now get even numbers. Now, most of you have used link, but do you understand what it is you're seeing here? Can you read the signature and can you explain this to somebody who's never used it before? Most times I've found that people, it's the where method, I know how to use it, right? It's kind of like, again, it's sort of, it's automatic. It's not necessarily understanding truly what it is. It's from memory, if you will, or something, right? What I'm trying to get you to understand is being able to read that signature. So the signature says here, if I were to tell you this in English, I'd say, okay, the where method, in this case, the int is just the generic type parameter that's become like a closed generic type because it knows that numbers is an int. So it's just showing it as int. It's really a t. So the where method takes a func of type int bool whose argument name is called predicate. And it returns an enumerable of, in this case, integers. Right? So all in our case, potentially even numbers. But what the heck is a func int bool? A func is another delegate type defined in .NET, the base class library. And they have, I think, 16 or 17 or whatever number of overloads defined, predefined. Right? So in this case, it's taking one argument. The func is a delegate that takes one or more arguments or 0 or more arguments and will always return something. So the func delegate type always returns something. And so the way you read this is the last generic type parameter here, whatever it may be. If it's only one, that's the return type. And if there's more than one, then the last one is always the return type. So in this case, this is some method that takes an int, returns a bool. So again, for a func, it has to return something. So if you see only one generic type argument there, then that is the return type. But if it's more than one, then the last one is always the return type. All the preceding ones up to 15 or 16 or whatever the number is will all be input arguments. The last one will always be the return type. We also have actions. Like func, we have actions that are predefined in .NET where actions have no return type. They never have a return type. They only have incoming arguments. Again, you can go between 0 and 16 or 17 input arguments. Don't design methods like that. 17 arguments. That's a feature that's available out of the box in .NET. We also have a predicate type predefined in .NET. Similar idea, similar concept. So now typically what we would do to implement this, most people will say, okay, then I'll just take, in such that in mod 2 equals 0 to get the even numbers, right? And I got even numbers. Now that's a lambda. And we'll talk about what a lambda is specifically, like a little deeper, or what's the difference between delegates, anonymous methods, and lambdas in the same idea, same session here right now. But this people can do. This is kind of out of memory. I want you to understand deeper what's really going on or what you could be doing besides doing that. Remember, the where method says it needs a func of type int bool. A func of type int bool meaning a method that takes an int argument, in this case int only because the numbers is an int, and returns a bool. So how about we define one? How about we say, so we know it has to return an int, and let's call it even numbers, that takes int bool, right? So it takes an int, returns a bool. Sorry, so this should be returning a bool. And this takes an int. And here, I'll have the same implementation. This is number mod 2 equals 0. Let's return the bool. Now, because this signature matches the signature of the func type that the where method requires, I can substitute that code for this. Right. Now, this is, first of all, I find most people are confused with that. Oh, okay, you could do that. It obviously now becomes very obvious, but that's really what it is. All right. So if you understand this, then you're saying, okay, so when would I use one or the other? And what's the difference between a delegate? Because in this case, this is a delegate. How is this a delegate? Well, because this is what's going on. It's saying this is nothing but a new func in bool, right? That is a delegate that takes a target. That's what's going on. Behind the scenes, when you see that, it's just doing that. your lambda is a little different. But let's get to that then. So how would I use this where clause? The where method, I mean. Where clause. Using a old style delegate, or what we call anonymous delegates. Right? So this is, of course, we saw just now that we use this delegate or this method as a delegate by newing up a function bool and passing in this method as an argument. So that's a key thing to understand. But what if I say something like delegate int n and that, and over here say return n mod 2, like that. That's valid too. This is what we call an anonymous method in .NET. In other words, it's a method, delegate, but it has no name, so you can't call it. There's no way for you to kind of execute it besides just overwrite here, sort of, as it is in here. And this was available to us, I think, in don't quote me on this, but I think .NET 3-ish. Yeah, I think .NET 3, yeah. Because we got lambdas with link, and then I think that was .NET 3.5, I'm not sure, but somewhere around that time. So we had anonymous methods. We had delegates. So the difference is, this was the delegate if I used it directly. This is an anonymous method. And the C# team said, well, if we want folks to use link, that is going to become really tedious. We need a more succinct way to help them define delegates, right? So they said, well, since we know the signature, we can assume it's a delegate, so we can take this thing out. That's just too wordy. And most times we don't need the curly braces here, so we can just say, we're just going to do that. So they can distinguish, or at least the reader can distinguish between the arguments and the method body, right? So this is still valid. And they said, well, that's also is cool. This is what we call a lambda statement block. Still valid in C#. It's a multi-line thing, statement block versus a statement expression. Lambda expression versus a lambda statement block. So this is a lambda statement block. But most times people don't need multiple lines. So what if we could kind of take out this curly? And we, of course, from the signature, we can decide or determine whether something in here is going to return something or is just doing something. So we don't need to have the return method specified there. And, well, it's a single line. We don't need a semicolon, of course. And then because of that, we don't need the curly brace. And this is a lambda expression. You saw how I got morphed into from a delegate to a lambda expression. So in other words, delegates, lambda expressions, lambda statement blocks, they're all the same. Behind the scenes, the C# compiler at compile time takes that code that you have here. Oh, this is another thing. They say, well, from the signature, we can also determine the type of this input argument. So we don't need this type. And well, if you don't have that, why do you need to have these parentheses? And so you can do that, right? So only time you need parentheses is if there's nothing, no arguments, or if there are multiple arguments, you need to have the parentheses. But otherwise, you can just do that. By giving us the feature of lambda expressions, link became more feasible, if you will, with regards to the usability of it. Otherwise, that would have been too tedious with the anonymous methods. So this is the difference now. Again, going back to what happens at runtime. At compile time, the compiler takes this and it produces a method, an anonymous method, if you will, and then compiles it. And then it goes back to the same thing. It says, I'm going to new up a function bool and assign it to this anonymous method, right? The magic is, or what you call syntactic sugar, is helping us use or write more succinct code, but behind the scenes is still compiling it down to the old style delegates, and you new up an instance of a delegate and provide that method, argument there. So in other words, this would be something like new. I've actually never done this. Func int bool. I don't know if it's going to take that as a method argument. Yeah, it does, right? So it's newing up an instance of function bool, and it's taking this delegate lambda anonymous method as an argument, because that's what the function bool requires. It needs a target that is of some method, right? Or what we would call it, like an instance or a target of a delegate. So you can do that. But of course, we don't have to write this code, thankfully. So we can take this out. So I'm hoping you learned something new. I mean, certainly don't have to write that kind of code, but at least you understand the magic. There are many, many times when the magic in C# gets in the way of you learning the language. Now, I tell people when I work with this, it's if you know training wheels on cycles, I say learn cycling first, put the training wheels on later. So this is the sort of the training wheel. This is before you have to learn the cycling, which means you have to understand what's going on under the hood, so that when you see the magic, it makes sense. So that's the sort of the meaning of that phrase that I use. All right. So if you figured this out, now let's do something else. We know this is a function bool that takes a parameter of type function bool. So what I could do is something like this. I could define a variable here of int function bool. Now let's call it, and I can assign it to that. So now what we have is, we don't necessarily have an anonymous method. We have a delegate, if you will. This is a delegate. And then this is newing up the delegate like we saw before. This is really saying new function bool, blah, 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 right? We saw earlier, same thing. So that's basically going on behind the scenes like that. So we don't have to actually do this ourselves again, thankfully. So I'm defining the implementation of this delegate at the time of defining the delegate instance, if you will, delegate variable itself. And I have now a delegate that matches the signature. So I can do that. And that works just fine. However, remember, we are working in C#, which is a strongly typed language. So this is what I'm going to do now. This even numbers has the same signature we require, which is a method that takes in and returns a bool, right? So what if I were to do this? I'd say, okay, so I'm going to define another delegate here. Returns the void that takes in a string argument. Int. Same signature, right? My func takes an int, returns a bool. What am I doing? All right. So now this my func, I'm going to define a method called myfunc. I'm going to call it myfunc variable. I'm going to assign it to even numbers, same signature, right? So the signature is the same as this. So I should be able to replace this with that. And this is not going to work. Yeah, this is not working. So this is argument 2 cannot convert from console myfunc to function bool because they're two different types. They look the same. They feel the same. This is not duck typing, right? So in duck typing, you say if it looks like a duck and it quacks like a duck, or it looks like a duck and it walks like a duck, it must be a duck. We actually do have duck typing in C#, unbeknownst to most people. And that'll probably make that the next video on So You Think You Know C#. That shows you where the heck in a strongly typed language we have duck typing. Duck typing is more for like dynamic languages like Ruby and Python and stuff like that. Anyway, this is not duck typed language here generally. So you can't do this. Even though even numbers can be put in here like that, you can't actually do that, right? Because you're assigning, remember, this is saying this is a new myfunc, and immediately you should say, okay, yeah, now it makes sense, right? I don't need the int bool because it's already defined as myfunc. It takes that. So this is an instance of myfunc. So of course you can't pass a myfunc in here. But when I do even numbers directly in here, well, you know what happens to that. That is nothing but it says new function bool again. So that's why it works like this. Make sense? Okay. Listen, as a senior software engineer, a C# engineer, you have to know these things. I mean, that's my opinion. Maybe I'm wrong. Maybe people think it's just useless information or you don't need to know this stuff. You have to know, because it's like the example I give people at work is it's a metaphor. And actually I've used it in one of my other videos on, I think, the memory model and performance in .NET part 1, maybe it's part 2, I forget. And it goes like this. You drive a car, right? Yeah. Okay, good. So you drive a car. You can imagine, let's say you're going on a hilly road, all the curves and going up the mountain and all that. And if you do that road multiple times, you start to learn every bend, every turn, even the blind ones. And you understand, the potholes, how fast you can go, how fast you can negotiate that turn. You start to learn the road. You become a better driver on that road, right? If you're going on the road for the first time, you're not going to be as adept at doing that sort of, let's say, fast driving. If you're one of those kinds of people like me, then if you were to do it multiple times, and now you understand the road. It's the same thing with C#. As a senior engineer, I would expect you understand the car and the road. That's your C# compiler and the operating system, or maybe it could be the runtime, the jitter, all those things that come sort of below the car, if you will. Right? So as a senior C# engineer, you have to understand these things. You need to understand the language, the compiler, the jitter, the runtime, the operating system, and maybe the hardware as well. Maybe a tall order. And maybe you don't aspire to be that kind of a senior developer. That's fine. It's choices you make. But that's the point of this series, is to make sure that you understand what you're supposed to understand at that deep level. All right. So once we've understood all of this, I think this brings us to the end of this section, not yet this video though. So I think I've kind of gone through this whole process here with delegates. I won't go through the whole actions and stuff like that, but I want to show you the fact that this is strongly typed. Okay, now to the next section. I've got a different project here, and I'm going to explain the problem statement, and then we're going to see how to do it. We're now moving on to higher order functions. This is a concept from functional programming languages like F# and Scala. And is Scala functional? Yes, I think Scala. Yes, Scala is functional. And OCaml and a bunch of other languages, modern, newer languages. Haskell is I think, the grandfather of all functional languages. The idea in functional languages is they only have functions, they don't have classes. So what they are able to do is they're able to pass functions to other functions as arguments, and they can get functions back from functions as return types. Well, we can do that in C# too with delegates, right? So we start using delegates in that fashion. And in fact, Link is all about functional, right? In fact, the person that, dreamt up Link or helped develop Link in Microsoft actually had a Haskell background. Eric Meyer, I forget. Eric Meyer, I think that's how you pronounce it. The Danish guy. These Danes, I tell you, between Anders Hallsberg and Eric Meyer, and now the new sort of C#, what do they call them? Program manager or compiler person. I forget his name. Also Danish. The Danes, I tell you. He sort of designed and envisioned C# along with, I think, Microsoft Research, the F# people, and Don Syme, who's the head of the F# research team and the F# language itself. So Link is functional, right? You say where, and where takes a function or a delegate as an argument. So one method is taking another method as an argument. So the where method and pretty much every other Link method is making use of higher order functions. Now, we won't talk about higher order functions and polymorphism or delegates and polymorphism in this video. That's a really interesting topic. I'll probably make another video on that. This video is probably going to get too long otherwise. But that's how functional programming people pull off what we would consider a polymorphism. They don't call that polymorphism. I don't know what they call it, but they get the same capability, right? By passing different functions into a method, you get different behavior, which is what polymorphism is, right? You give a different instance and you get a different behavior because you're calling the same method on it. Same idea. We won't talk about that in this video though. In this next part, we're going to talk about higher order functions in a sort of more useful, I shouldn't say that is not useful, but something I use a lot, and I do pretty much in every one of my projects. And it's also like an exercise, if you will, for you to understand higher order functions and how you could design your own. So the setup is this. I'm using this single method, right? And it's saying I want to filter out all movies from this collection of movies that I have a year 2019. And that should be the required movie. Now, of course, single returns a single movie. The assumption here is that there is only one movie for the year 2019. I have this collection of movies here. Now you can see here, there's many movies. Where does it start? From here to here. So that's, 7 movies, right? So we know there's 7 movies for 2019. The single is going to blow out because single says, give me the one and only thing that matches this criteria. So if you have more than that one thing, it's going to throw an exception. If you have none that match the criteria, it's going to throw an exception, right? Which is the expectation of single, right? If you wanted the first out of many, you would say first. So when you say single, you're saying, I know there's supposed to be exactly one matching this criteria. Please give that to me as a singular thing. In other words, it's not a collection of movies. Here, it's simply a single movie here, right? All right. So my issue with this, and you have to probably run this application to see my issue. So here we get an exception, as we expect. We expect the exception, but the problem I have is not the exception itself. The problem I have is with the messaging that comes with this exception, right? It says invalid operation exception. Really? How the heck is that an invalid operation? I mean, you can tell me something else, right? But just don't call it invalid operation. Yeah, I'm a big fan of exceptions, but for me to enjoy exceptions on the receiving end, meaning I am a big fan of throwing exceptions, but if you want me to receive your exceptions, I expect them to follow certain sort of minimal requirements, if you will. One of them is the proper name. Invalid operation is not it. At least I don't believe it's the right name. But what's worse is sequence contains more than one matching element. All right, I mean, I get it in this small little application, right? Imagine a larger application and you're using single in 25, 30, 50, 2,000 different places. And you get this exception logged in your logs in production. What sequence? How many more elements? Like, why is it not? Of course, you're using single because you're expecting exactly one, but for whatever reason in production, you have a problem, right? And looking at the exception messaging, what sequence? Like, what was I doing that it caused this problem? And hey, do you mind telling me how many elements you found so that it's going to help you in debugging and figuring out how to fix it, right? My aim with the exception messages is the exception messages should be really clear. It should give the exception message should give me all the information it could possibly give me to help me understand the problem and then fix the problem without even trying to dig into code and trying to reproduce the problem and all this sort of thing. In other words, in this scenario, what I would like to see is this. First of all, from the call side, meaning where I'm calling the single method from there, I would like the option to define the exception type to be thrown. I know I'm working with movies here, or somewhere else I'm working with something else, and somewhere else I'm working with something else. So wherever I am at the call side, from the call side, I want to be able to define the type of exception to be thrown. Like, I don't want it to say, I'm going to throw an invalid argument exception. I want my own specialized types to be thrown for the different places in which I use it. So this contextual to the exception type is contextual to the context. Contextual to the context. You get what I'm saying? All right. The second is I want the messages to be clear. In other words, I would like to hear something like, hey, I was trying to get a single movie that matched this criteria, the value in this case, 2019. So I can say in this case, I know I'm looking for 2019 is the year. So my message should say, I was looking for movies made in the year 2019, or I was expecting to find exactly one movie for the year 2019, but 7 were found. And on top of that, I would like to see what those 7 are. I mean, so that I can sort the problem out without having to debug and reproduce the problem and all this sort of thing. In a larger organization, you have the analysts on your team doing the triaging. When the issue occurs like this, they'll look at the log file and they'll see this message. Now, when they say sequence contains more than one element, they're going to throw it right in your face and say, guys, devs, please go fix it. Right? But they have no information at all. However, if they saw a message like this, we were expecting exactly one movie for the year 2019. And this is contextual information. 2019 is contextual from the call side. The fact that I'm filtering on movies in this case is contextual on the call side. So we were expecting exactly one movie for the year 2019, but we found 7, and they are the movies and, let's say, the titles and the genre and the year and everything kind of part of the exception message. The analyst looks at that message and say, oh yeah, this looks like a data fix. We need to go and talk to the other team and get them to fix that data. Right? You never saw the problem. They didn't call you because they can understand the problem because it's now in business terms. It's not in some technical thing. Sequence contains more than one element. Like, what the heck is that? How are they supposed to understand anything about that? Anyway, so that's what we're going to do here. For moving on from here, we want to have our own single method that does exactly what I just said. All right. So that's the point. That's the point of the exercise. That's the business requirements that I just gave you. And let's go start to implement this method. So I'm going to call this method single else exception. I'm going to make this an extension method. What? I'm making an extension method? I don't know if you guys have heard. Did I make a video on Let's Talk extension methods? No, thank you. Okay, so I'm going to define a internal static class called enumerable extensions. Now we are extending IEnumerable, right, just in case you're wondering, because we are extending this IEnumerable that we want to see a single else exception on here. All right, and this class is going to have a public static method. Single, if you look at the signature here, let's read the signature in case you're trying to wonder what that is. What's it saying? It's saying I return a single movie, but I take in a movie bool. Of course, this is a T, generic type parameter, really, bool, that it calls predicate. Okay, so we're going to match the same signature. We want to keep it similar to single. So it's going to return a T in the sense we want to make this a generic method, not tied to movie. I'm going to call it single else exception, and we're going to define the generic type argument, and this is an extension method, so it's going to say this, which is an IEnumerable of T, and it's going to call it sequence. And then next thing is going to be the func, not in bool, but func T bool. And they're going to call it predicate. So this is really the existing signature of single. Right? We're going to start here and then we're going to extend that. And then over here, I'm just going to use single else exception. So, sorry. Okay. So now let's implement this. So essentially to get a single, you would iterate over your sequence. So let's say we call this item and sequence. And then here we'd call predicate. And if predicate sending it the item, if it returns true, then we'll accumulate this in some sort of a collection. So we'll just say here, it's a new list of T, whatever the T might be in this case. And here now we can say matched items dot add item. Right? So if it matches the criteria, the predicate, then add it. And once we're done with all of this, if matched items dot count equals 1, then we can return it, right? Because that's a single. So cool. However, if it's not return matched items of 0. Now, if it's either 0 or more than 1, that's a problem as per the singles definition of the original single method. So we're going to follow the same definition. The only thing we are trying to do now is to get a better control over the kind of exception being thrown and the message being put in the exception message and stuff like that. All right. So for the most part, this is kind of, let's say, a similar implementation to single. All right. So now the next part is, what do we do now? So basically in the two cases, which is a 0 or more than 1, it's a problem. And I'm saying the requirement says that the call site wants to control the exception type to be thrown, and the call site would like to be able to construct the exception message. But if you remember when I described the exception message to you, it also contained the details of the movies, not just the count, but the which movie, like by title and the genre and the year and things like that. So, I mean, let's say you're working with something else, we're working with customers, and you found more than one customer and you find 5 extra customers. You can list out their names, their email addresses, phone numbers, what have you, in the exception message. So the call site needs to control that, or have control over what is that exception message going to be like, and what exception type is going to be thrown. This method here is just an extension method, so it really doesn't know, or should not know, the details of any of that. So it has to give you the ability to do that, the call site. So the way we're going to do that is you're going to add another argument here. At the call site, so imagine the call site calls single else exception, and as soon as there's a problem, it wants to know what it is, what's the problem, right? Which means this method, the single else exception method, needs to give it the matched items it found, so that the call site says, oh, there's 0 items, I can change the message like this. Oh, there's more than 1 item, I can change the message to that. It can construct the message, and it can then return the type of exception. So essentially, it could create an instance of an exception with that message in it and return the exception, and this end can just throw the exception. Sound simple? Okay. Well, if that's the case, then we define this method here. Let's call this, this is a func that takes an enumerable of some t, and it returns an exception. Where we can call this exception factory, right? And then over here, all this thing needs to do is going to call exception factory, the delegate, giving it the matched items, right? And it knows it's going to come back with an exception. It's going to simply throw it. That's it. Done. Now, let's see how this works on the call side, because that's the other part of designing classes or a higher order function or whatever it is. You have to understand, how does it look like? Is it good or convenient from the call side's perspective, right? Not from the implementation side, but from the thing that's going to use this thing. So let's look at what that's going to look like here. What is this complaining about? So extension method must be defined in the top level static class. What is this then? Where did I define this? Oops. How did it get here? Oh, it became a nested class. My mistake. Okay. Happy now? Good. Okay, let's look at the call side. So single else exception now says this. It says, hey, I certainly want a func of movie bool, the predicate, but now I also want a func of an enumerable of movie exception, something called exception factory. We need to provide that over here. So we put a comma. So okay, we're going to get a collection of movies. I'm going to call it matched movies here. So I'm clear what this is, matched movies. And I can then implement, and somehow I need to throw an exception. Let's define an exception. Let's call this exception, this is single else exception, but this we're doing with movies, and so I'm going to call it filtered movie exception. Okay, just to kind of, I'm going to define this exception here. And what I would do here is certainly make this sealed. And then of course, for that, I need to make this protected method private. All right, so we got our exception. So over here, we're going to say return new exception. Oops, not new exception, new filter movie exception. and some message. All right, that's it. Now I haven't implemented the message part, but you can understand here inside of this lambda or lambda expression statement block, I have access to required year. So if I came here, I could actually access required year, right? This is available. I have access to the matched movies. So I could construct an exception message. This is okay, something like expecting to find exactly one movie, but we found so many movies instead, and they are blah, right? They are something. And of course the found over here will be matched. Matched movies.count. I'm not going to go through the whole exception message here, but essentially I'm just trying to show you that we have access to all the information we need. We have access to whether this count is 0 or 1, so we can change our logic is saying if it's 0, then the message should be that, but if it's more than, if it's not 0, the message should be that. I'm just assuming here the message is more than 1, right? And also we have access to this, and the fact that we are dealing with movies is all contextual here. So all the information we require to construct the message, exception message that I was describing in the beginning of this section is doable from here. Okay, but I'm just going to simply just show you that. And let's come here. And if you were to run this now, it throws an exception, right? And it says, we were expecting to find exactly one movie, but we found 7 movies instead. And they are blah, 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 blah. And the type of the exception is filter movie exception, right? It's contextual to the fact that I'm dealing with movies here. If I was dealing with customers over there, if I was dealing with, I don't know, whatever else, it's all contextual. So this implementation of a higher order function, or in the case of extension, and of course then using it as a higher order function, satisfies the requirement as I stated it before the session, this part of the video started. All right. So I'll leave the sort of the starter project, if you will, on my GitHub for those who want to experiment and start from that starter project that I just had. And then you can, of course, watch this video to see if you're making mistakes and how to complete it if you want to practice that. If you haven't done this sort of thing before, I highly suggest do this. I'm not necessarily a big fan of using higher order functions everywhere in my system, but as a C# programmer, if you've done C# for more than 2 years, this is something you have to be really familiar with, at least in my opinion. So anyways, I hope you enjoyed this video. If you have, please give me a like or a thumbs up. Please subscribe. You know what I noticed is for some reason, there's more non-subscribers watching my videos than my own subscribers. It looks like I've got about almost 4,500 subscribers now, thanks to my existing subscribers. Please, if you haven't subscribed yet, please subscribe. There's lots more to come, and you're going to enjoy them if you enjoyed this one as well. All right. And I will see you next time.